welcome. In this video, we're going to be looking at converting between a count of bonds or atoms and moles, but this is what I call a level 2 type calculation. This is something you'll more likely see in general chemistry, AP chemistry, or IB chemistry. And that's because we're going to convert the mole that's in the denominator instead of the numerator. Now, there are a couple of ways to do this, but I want to show you this way in particular because it applies to so many different types of problems that you will come across. So in this case, we have two chlorine atoms, and there is a single bond between them. And the problem tells us that if I want to break that bond, now it takes energy to break a bond, takes to break, freeze to form. And it tells me that energy is 242 kilojoules for every mole of Cl2 that I'm going to break the bond. Or you can think of it as for every mole of bonds that you have. So I'm going to write it this way. I've got 242 kilojoules per 1 mole. And I'm going to need to convert the numerator so that it's in joules and the denominator so that it's in bonds or per 1 bond. Usually that wouldn't be recorded as per 1 bond, but I want to show you this setup so you can see how that's actually implied when you see those values. So I'm going to start with my 242 kilojoules. I'm going to get a grid here. It's going to take 2 steps. I've got to convert moles to the count of bonds, and then I've got to convert kilojoules to joules. So make sure you put that 1 mole in the denominator, okay? So I have moles. I'm going to convert this first. So we've got to convert moles to bonds. I want to get rid of moles, but this time moles in the denominator. So to eliminate it, I'm going to put it in the numerator. And I want to convert that to a count of bonds that could be broken. How many of these individual bonds could be broken? You'll see that if we're going to break a bond with light, 1 photon of light will break 1 bond. So I've got 1 mole. A bond is something I can count. And so that's where we'll use Avogadro's number there. Okay, so I've done the denominator. Now I want to do the numerator. I have kilojoules. That's pretty straightforward. I will tell you, though, that if you tend to be a decimal shifter, caution. I was grading the AP test, and decimal shifters tend to lose points. For one, you need to show all work leading up to your final answer in order to get credit. 2, I can't tell you how many times kids who are so bright shift the wrong way. So don't be a decimal shifter. Show your work. 1 kilojoule is 1 times 10 to the 3rd joules. And our answer to 3 sig figs would be 4.02 times 10 to the minus 19th joules. Okay, now that's of a photon of light. That's the energy. So from this, we could go to wavelengths or frequencies. You can't go to wavelength or frequency when you have kilojoules per mole. This is technically joules per bond, but often you'll see that bond neglected. They'll just say joules for that bond is implied. I wish they wouldn't. I hate it for you. Okay, now let's do another one. We're going the opposite direction this time. And we have 8.22 times 10 to the minus 19th joules. This time we're going to break a double bond between 2 oxygen atoms. And we've got to go take the numerator from joules to kilojoules and the denominator, and this is again why I do it this way, because I want you to see it says the energy required to break the double bond. So what's implied is that that's joules for that one double bond. It's implied there. And I wanted you to see this because, it's just kind of assumed you should know that. Again, there are other ways to approach it, but I hope this helps you understand some of the implications in the way numbers are reported. Okay, I like to deal with my denominator first. I've got bonds in the denominator, so I'm going to put it in the numerator to get rid of it. And I need moles, right? It says to convert to kilojoules per mole. A bond is something you can count. So 6.02 times 10 to the 23rd goes there for every 1 mole. Joules to kilojoules, don't be a decimal shifter. For every 1 kilojoule, we have 1 times 10 to the 3rd joules. And we would report that, and you will see this in another aspect of chemistry, is you'll see tables of bond energies, and they're listed as the energy required to break, so takes to break, so they're listed as positive values. 495 kilojoules per mole of O2 that we're breaking those bonds in. Thanks lots. Take care, and thanks for joining me.